In this lesson, we're going to go through position versus time. So we're going to start by going through a couple of definitions. The first one is kinematics, and that's the science of describing motion of objects using words, diagrams, numbers, graphs, and equations. And in this lesson, that's what we're going to start doing. So in math, you may have heard these terms before. Scalar is a number that is described by magnitude alone. So like 1 kilometer. So it's only a number. A vector has both a magnitude, so a number, and a direction. So like 1 kilometer north. That would be an example of a vector. So again, scalar is just a number. Vector is the number with the direction. So we're going to go through and we're going to identify each of the following as a vector or a scalar. Okay, so for the first one here, we have 5 meters. So 5 meters would just be a scalar because there's no direction attached to it. The next one, 30 meters per second east. Because it's east, it has a direction, it would be a vector. 5 miles north, again, we have a direction here, so this would be a vector. 20 degrees Celsius. No direction, just a number. It's a scalar. 256 bytes. That's a computer measurement. That would just be a scalar. There's no direction here. And then finally, 4,000 calories. Calories are just a scalar. There's no direction attached to that. Okay, 2 other definitions that we need to go through. The first one is distance. Distance is how much ground an object has covered during its motion. This is a scalar quantity, meaning it does not have a direction attached to it. The standard unit that we're going to use for distance is the meter. And an example of distance would be 100 meters. Displacement is how far out of place an object is. An object's overall change in position. This is a vector quantity. We're going to use the same unit, which is the meter. And an example is 100 meters north. Since we have a direction, this would be a vector. On the diagram below, if you started on the dot and walked 2 meters north, 4 meters east, 2 meters south, 4 meters west, what would be your distance and displacement? So for distance, we're going to go here. So we've covered 2 meters. Then we're going to go here. So we've covered another 4 meters. Then we go here. So we cover another 2 meters. And then finally here. So it's going to be 2 plus 4 plus 2 plus 4. So that would give us a total distance of 12 meters. Now, with displacement, displacement is a little different. For displacement, we started and ended on the same spot. So because we're starting and ending on the same spot, there's no overall change in position. So my displacement would be 0. I started and ended on the same spot. All right, let's take a look at another example. It says the diagram below shows the position of a cross-country skier at various times. At each of the indicated times, the skier turns around and reverses the direction of travel. So in other words, the skier moves from A to B to C to D. Use the diagram to determine the resulting displacement and the distance traveled by the skier during these 3 minutes. So let's start with distance. Distance, we're just going to add up all of the distances we covered. So from A to B, we're covering 40, 100, and then 40. 40 plus 100 plus 40 is, so from A to B, we're covering a total distance of 180. Okay. And then when we go from B to C, we're going to cover 40 and 100. B to C. 40 and 100 is 140. Okay, so, and then we have to go from C to D. Going from C to D, we just covered that 100. So to get our total distance, we're just going to add up those three numbers. So 180 plus 140 plus 100 is 420 meters. So that's the total distance that we covered. Now, displacement is a little bit different. So displacement, we look at where we started and where we ended. Okay, so for displacement, we started here at A, and we ended here at D. So how far away are we from where we started? So we have to look at how much distance we're away. So we've got 40 and 100 to go from A to D. So 40 plus 100. So we're 140 meters away, but we're also to the right. So 140 meters rightward. All right, let's look at another example. It says, consider a football coach pacing back and forth along the sidelines. The diagram below shows several of the coach's positions at various times. At each marked position, the coach makes a U-turn and moves in the opposite direction. In other words, the coach moves from position A to B to C to D. What's the coach's resulting displacement and distance of travel? So let's start with the distance. So we got to look at where we're traveling. So we're starting at 50 meters. So we're going from A to B. So we're starting at 50 and we're traveling to 15. That's 35 yards that we traveled. Okay. B to C is our next jump. B to C, so we're going from 15 to 35. That's 20 yards. And then finally, C to D, we're going from 35 to negative 5. So let's see, 35 to 0 is 35. And then 0 to negative 5 is another 5. So that's a total of 40 yards. So our distance, we're going to add up everything we covered. So for distance, let's just add up what we've got. So A to B was 35. B to C was 20. And then we had 40 for the C to D. So we add all these up. So let's see. 20 and 40 is 60 plus 35. So that's going to be 95 yards for our distance. And then our displacement, we started at A and ended at D. So we need to go from A to D, 50 to negative 5. So we traveled a total of 55 meters to go from A to D, and D is to the left of A.